All right, good morning, everyone. Today is Tuesday, November the 2nd, and we are starting Unit 4 today. This is our last unit of the semester. Are all of you really excited for that? Kinda, yeah. This is probably my favorite unit of the semester. Um, a lot of it's going to feel like learning math for the very first time, which is really cool. So you've probably seen some of it, like very little of it though. But yeah, it's probably going to feel like learning math for the first time, I think. Yep, the final's coming up. You did exponents and logs in algebra 2. Oh, nice. Well, yeah, we are doing logs and natural logs and exponents this unit. And I teach it very differently than how the module teaches it. So if you're someone that likes to go in and try to learn it first from the module, then come to class and then see how I do it, you're going to discover once we get into like the logs and natural logs, my approach is very different than how the module does it. The module does it from a formula perspective. So you have to like memorize formulas, which I've said it before. I'm not a fan of memorizing formulas to do math. I like actually learning and understanding the math and applying it, not necessarily using a formula. So my approach to logs and natural logs is a very mathematical approach, which is very different than how you're going to see in the modules. Keep that in mind. I think I do a better job of it. I think I like my way better, but you can decide for yourself if you like the way the module presents it versus how I present it. Well, using a formula is still mathematical, I guess. Well, you'll see. You'll see what I mean when we actually get into it. Either later this week or next week. I forget. Probably this week sometime. Yeah. All right. So let's get into it. And again, make sure you download the guided notes from the OHS. All of this stuff is already in the PDF file, so you can just kind of follow along until we actually get to the actual math part. All right, exponential functions. We have f of x, or y equals a times b to the x power. Now, to be exponential, your a value, your scalar, cannot be zero, because if it was zero, zero times anything is zero, and then it wouldn't be exponential, it would just be zero. Your b value, b raised to the x power, the base b needs to be greater than zero. Well, it cannot be negative. That'd be something else. Um, well, it can. So let me kind of get into this. Well, yeah, okay. So I'm kind of jumping ahead of myself. Yeah, it can be greater than zero. It cannot be negative. And your b cannot be one, because one to any power is just one, and one times anything is going to be that number. So you don't actually have growth. So again, the scalar can't be zero. The base must be greater than zero, but it can be a fraction. Like 1/2 is still greater than zero, so that's okay. And the b cannot be one. So it's just restrictions to be exponential. Domain, remember, domain is all of your inputs. Domain is all of the x values. So domain, your inputs, your x values all mean the same thing. So for exponential function, the domain is everything, all real numbers. Now the range really is determined by the vertical shift, which I'll talk about right here. So your range for all exponential functions, assuming there's no like vertical flip going on, is always going to be anything greater than zero. So interval notation, it's going to be from 0 to infinity. So if you were to graph this, it would approach zero but not touch it. So from 0 to infinity. And I'll show you some graphs on the next page. The a value, this causes a stretch. So it can either get really wide or really condensed. And I do have a slide showing that as well. Now for shifting, the H and K, this is kind of nice. This is carry over kind of from conics. The H is the horizontal shift, the K is the vertical shift. Now, a little different. Um, for the horizontal shift, just like conics, it's always going to be opposite. So x minus h. So if let's say it was x, I don't know, x minus 2. Well, it's always opposite. So x minus 2 would be a shift to the right, just like if it was a conic. However, the k value is the shift is how you see it. So this was like a plus 5. You are shifting up 5 units. If that was minus 5, you would shift down 5 units. So a little different thinking than conics. Domain is all real numbers, of course, just like if it was no shifting going on. And the range for the parent function, I call it, it's from 0 to infinity. Now, because of a vertical shift, whether it's up or down, determines your range interval. It's all based on the vertical shift. So if you shifted the whole function up 5 units, well, it would be from 5 to infinity. If you shifted it down 5 units, it would be from -5 to infinity. Pretty simple. Again, range is really determined by the vertical shift, and it's also determined if we happen to flip our function, which we'll talk about here in a bit. All right, so vertical shift. This is when your k value is, well, anything other than a 0. So this green graph right here, this is just y equals 3 to the x power. The range for this is, well, 0 to infinity. It doesn't matter what the base is. It could be anything. It's still going to be 0 to infinity. Now, this blue graph has a k value of 2. So this shift is up 2 units. And now that's why from 0, this 0 became a 2. Because, well, we just moved this up 2 units. So remember, the range is your y value. So for the parent function, y equals 3 to the x power, our graph approaches 0. It doesn't touch it. It looks like it does, though, but it doesn't touch it. It just kind of hovers right above it. So it's from 0 to infinity. Remember, it's the y value. And then for this one here, this one has a vertical shift of down 2. So, well, we take this parent function and we just move it down 2 units. That's why the range is from -2 to infinity. Remember, domain and range is always least to greatest. It's always least to greatest. Smallest value is 0, largest value is infinity. And this shouldn't be anything new. It should all be review still. Horizontal shifts. So we got our parent function, y equals 3 to the x power. This blue graph here is y equals, or f of x equals 3 raised to the x plus 2. Remember, this is always opposite. Now, because this is x plus 2, this tells us it is, they take this original parent function and we just shift it left 2 units. So we'll use this y-intercept, easy to see. 0, 1, we shift to the left 1, 2 units. Shifted left 2 units. That's what this does. And then for the red graph here, this is y equals 3 raised to the x minus 2. Because it's always opposite for horizontal shifting, we take this, start with this intercept here, and we are shifting to the right 1, 2 units. So that's how the shifting works for vertical and horizontal. And looking at these 3 graphs, class, what is the range of all 3 of these functions? Oh, my water's in the kitchen. Dang it. What is the range? Is range the X or the Y? The Y value. What is the smallest Y value that we have on this graph? 0. What is the largest Y value? Infinity. So class, what is the range of these three graphs? 0 to infinity. That is correct. Remember, going back to this, if you've already forgotten, your range is always 0 to infinity unless we have vertical shifting. So if you were to take, so let me go back to this one. So the range of this one, we're shifting down 2, so it's from -2 to infinity. This one has no shift, 0 to infinity. This one has a shift of 2 going up, vertical shift. So this is from 2 to infinity. These do not have vertical shifts. So you can kind of think of the range. If you were to take your graph and you were to go left side, right side, and you were to smash it right to the y-axis, right down the middle, it would create a vertical line. The smallest it gets to is 0 without touching it, and it goes from 0 and up forever, 0 to infinity. That is range. All right, we're all good? Everything's crystal clear? Okay. All right, stretches. So when your A value is something other than a 1, can't be a 0. So we have the parent function, y equals 3 to the x power. This one has y equals, or f of x equals 2 times 3 to the x power. So when the A value is greater than 1, it causes the graph to become condensed. In other words, they're taking the original graph and they're kind of squishing it. It becomes condensed. Now, if your A value is less than 1, but still positive, so like this 1/2, because it is less than 1 but greater than 0, this causes the graph to become stretched. So they are pulling it, making it wider. Class, what is the range of all three of these graphs? Zero to infinity. Very good. So here's another question. What if A is negative? What if it's negative? Well, I kind of gave the answer. When A is negative, what happens to our graph? It flips. Yeah, it flips upside down. We are still having a vertical shift up 5 units. We are having a horizontal shift left 1 unit. The 2 causes our graph to become condensed or squished, and the negative causes the entire graph to flip upside down. Remember, range is all the y values. So looking at this graph, using the shifts that are given to us, what do you think the range is? We got one person that has an answer. Anybody else? Remember, Brady, look at the graph to help you. And remember, this is range. Range is your y values. We don't care about x. X is domain, left to right. So range, vertical, top to bottom, bottom to top, whatever. Don't forget, it must be least to greatest. Always least to greatest. So looking at this graph, what is our smallest y value? Negative infinity. What is the largest y value we get to without touching it? 5. Now put that together. Negative infinity to 5. Parentheses. Yes. Negative infinity to 5. This goes down forever. So the smallest y value we get to is negative infinity. The largest, the highest point we get to would be approaching 5. And that's based on the vertical shift. Whether you can see it, like you probably have to zoom out and see how it gets really close to 5. It doesn't touch it. And that's why it's a parentheses and not a bracket. So least to greatest from negative infinity up to but not touching 5. Range is bottom to top, least to greatest. I know he did. I was waiting for just more than one of you to give me the right answer. Because remember, Enzo did give me the answer to the previous question, and he was wrong, and all of you followed suit. Oh, sure you did. Right. All right, everyone. Let's do the range for all four of these. And as you're doing that, I'm gonna grab my water from the kitchen. I'll be right back. All right. Give me a green check when you're done with the first one on this page. When you're done with number one on this page, give me a green check. Okay. All right. Number one. What is the range? 1 to infinity. That is correct. All right. Give me a green check when you're done with the remaining three problems on this page. Still waiting for one of you to finish up. I'm not sure if you're AFK or you're still working. All right. What is the answer to number two? I saw some of you put it in chat already. Negative infinity to negative two. Yes. And this one right here, we have a vertical shift, so down two, but this negative causes your graph to flip. So if you go to Desmos, yeah, so like on a quiz, on a test, you're going to have the time, and I would recommend graphing these as well to confirm what you think the answer is. So like this one right here, it flips, and also we shift down 2 units. So it looks something like this in Desmos. And yeah, so that's from the smallest y value, like all of you are saying, is negative infinity. And then the largest it gets to would be -2 without actually touching it. So that is the range for number two. What is the range for number three? All right. Looks like two of you think it's from -1 to infinity. Rest of you fell asleep. Oh, there is a very good reason to say it a third time is because I asked everyone what is the answer to number two. So it is from -1 to infinity. All right, number 4, what is that answer? 2 to infinity. Good. All right, how's everyone feeling about about finding the range of exponential equations? Hopefully pretty good. You just really just use the vertical shift, and then knowing if it's going to be flipped kind of really affects um, where the infinity symbol goes. Yeah, not too bad. People that are actually here and listening. Alexis, not here. You are here. Okay. All right. Graphs that have no shifts. Now, we kind of already talked about well, actually, no, we haven't talked about this already. So we did talk about when like your A value was negative, like when the A value was negative and it causes it to flip. But we didn't talk about when your base is between 0 and 1. So when your B value is greater than 1, we have growth. So like y equals 2 to the x power. Now, when we have your base, your B value is between 0 and 1, so a fraction like 1/2, it causes the original exponential growth to become exponential decay. So as we go forward in time, so the x-axis it usually acts as time, pretty much in all scenarios. So as time increases, the amount decreases and decreases and decreases, and it approaches 0. So decay. Whereas growth, as time increases, we get larger and larger and larger and larger. Don't confuse the B value with the A value. So going back to this is the A value. This causes the stretch or the condensing. The B value is what determines if it's going to be growth or decay. So the base of the exponent, B being the base, this being the exponent. So don't mix these up. Like this one right here. This flips it. Well, that's a bad example because we have a negative. Do I have one on this page? I don't. Okay, never mind. Scratch that. I don't have an example, but I want to say. Anyway, B value is between 0 and 1. It's decay. If it's greater than 1, it's growth. So using what we know about the equations, the A value for stretching, the B value for growth decay, the H for horizontal shift, the K value for vertical shifting, looking at A, B, C, and D without using Desmos, without using it, all of you should be able to look at this and determine which one is the correct graph. Now, looking at this equation, A, B, C, or D, which graph can't be the right answer and why? Yeah, B, because it's growth. This B value is a fraction between 0 and 1, so this is decay. This is decay. So A is a decay problem, C is decay problem, D is a decay problem. Well, B, this is growth. So this cannot be the correct answer. So nobody should choose B as the answer. Now, we have to use other characteristics of this graph to help us identify the correct answer. Now, sometimes, or maybe a lot of times, if there's no horizontal shifting going on, we can probably find one of our coordinates. What's an easy coordinate to find in this equation? It's a really easy one. When x equals what? 0. 0 is super easy. Any number to the 0 power is what? 1. Yeah. 1 to the 0 power is 1. 10 to the 0 power is 1. 1,000 to the 0 power is 1. So if you just plug in 0, anything to the 0 power is 1, and then 1 times 2 gives us 2. So I'm going to write this down. So a coordinate that's really easy to see is 0, comma 2. And all of you should be able to do that in your head. Anything to the 0 power is 1. 1 times 2 gives us 2. So 0, comma 2. So looking at A, B, C, or sorry, A, C, and D, which one is the correct answer? Let me do a little polling. It'll be easier. Which one is the correct answer? Looks like some of you walked away. That's the bad thing about live sessions is you guys will log in but fall asleep or walk away. All right. Oh, now I see. Yeah, it is C. C is the correct answer. And we can see that because choice C is the only one that has a y-intercept at 0, comma 2. This looks like it's like 0, comma maybe 1. And this one is 0, comma 4. So finding the y-intercept isn't always the best. Like if there was a horizontal shift, I don't know, I might not do that because it's not always easy. There's other characteristics we could have used. Vertical shifting is a good one. Sometimes horizontal shifting. Determining if it's growth or decay, definitely always a good one. Maybe if it's like more condensed, like if there's two choices that look the same, but one is more condensed than the other, that might be a good way. So let's look at another one here. All right, number 2, y equals 5 times 2 to the x power. I'll let you decide what you think is the correct answer and then go ahead and select it. And you shouldn't be tabbing out to type these in the Desmos. So you need to be able to look at an equation and determine what is the correct graph without using Desmos. Now, on a test or quiz, feel free to type it in and verify, but none of you should be tabbing out to Desmos. Still waiting for one person. There we go. All right. All of you got it correct. The answer is B. Yep. All of you got it right. Given this equation, which one of these is definitely not the correct answer? Like, definitely not. Yeah, choice D, because that is decay. And this 2 to the x power, this tells us it is definitely growth. So D is the worst choice. If somebody chose D, I question your ability. um, to do well on the rest of them. Maybe a little bit, unless you happen to mix these up, and that's easy to do. But based on this problem, nobody should have chosen D. Nobody did. And then from there, I think using the y-intercept is probably a good choice. So 2 to the 0 power is 1. 1 times 5 is 5. So 0 comma 5. This is 0 comma 4. This is 0 comma 1. This is 0 comma 5. So yeah, based on the y-intercept, B is the correct answer. So if there is not a shift, the intercept is always let me think about that. So as long as there's not a shift. So if you have a horizontal shift or a vertical shift, this number will not be the y-intercept. Again, if you have either a horizontal or a vertical shift, this will not be the y-intercept. 2 to the 0 is 1. 1 times 5 is 5. Yeah. Hopefully that answered your question. Yep. Yeah, A with no shifts. But I probably wouldn't give you an easy, like on your test or quiz, I'm probably not going to give you an easy problem like this. You're probably going to have shifts, either horizontal, vertical, or both. You'll probably have some stretching going on or condensing, and you might even have some flipping going on. Yeah, this is, I think this is too easy of a problem. Which leads me into something like this, something you'd probably see on a test or a quiz. So let me put that polling up, and then you can decide what is the correct answer based on what you see. And again, avoid using Desmos to give you the answer, because you really need to be able to look at an equation, know how the parts work together and what it's doing, and be able to pick it out from a graph. All right, looks like we're split between the correct answer and the wrong answer. And it looks like a majority of you chose the wrong answer. Any of you like to use the mic to explain the reasoning behind your choice? And the reasoning, whether you're right or wrong. Remember, most of you are wrong, so um, don't be afraid to give me your reasoning, whether you're right or wrong. I do want to hear it, or in chat, whatever. Right, so no takers on the mic, huh? Right, so let's see. So it'll be with no shifts, you said? Wait, that's not to that. Okay. All right, you want to hold on. Let me bring up the polling again. So if you happen to click the wrong choice, let me give you another opportunity to click the right answer. If you think you misclicked. Well, the majority of you still picked the wrong answer. The majority of you still picked the wrong answer. Now, the good thing is nobody chose A. And because that's decay, right? This is growth, this is growth, this is growth. This is 6 raised to this power. This is definitely growth. So the answer can't be A, which is good. Nobody chose A. The problem is more than half the class, which is there's only 5 of you here right now, are more than half of you are choosing the wrong answer. So let's see what else we got in chat. Let's try to figure this out. I'm not leaving you hanging. I just really want you to really think about your answer and if you agree with your thought. So we all know it's growth. Now we probably don't want to use the y-intercept. And yeah, let me tell you the reason. Because when you plug in 0, right, then you have 0 minus 2. So now it's 6 to the negative 2 power. 6 to the negative 2 power is 1 over 36. And then 1 over 36 times 1 half is 1 over 72. And then 1 over 72 plus 2 is like, I don't know, a fraction I can't do in my head, which is like 2 point something or other. So yeah, it's not. Yeah, you don't really want to use the y-intercept in this case because well, it's not easily found. So maybe we should use a different characteristic of this equation. Anybody have an idea of what might be used in this scenario with this case? What's something really easy to use other than y-intercept? Instead of using a coordinate or an intercept, what's something else? What other characteristic of exponential growth equations? So Enzo says the k value. So in other words, Enzo is saying use the vertical shift to help us find the answer. So if you weren't looking at vertical shift, look at it now, and then based on that, let's see if you change your answer. I'm trying to lead you down the right path without giving you the answer away, giving the answer away. So use the vertical shift to select the correct answer. Isaiah, you better not be in Desmos typing it in. Isabella, choose your answer. Oh, you changed your answer? Oh, Isabella. I think you got it right the very first time. So class, what is the vertical shift? Up 2 units. Anyone else agree? Are we shifting up 2? So looking at these graphs, remember the standard range is from 0 to infinity. Which one of these is shifted up 2 units? Yeah, choice B. If you notice, this graph, as we decrease in the x value, this graph approaches 2 but doesn't touch it. Choice D is definitely below 2, so it can't be that. This is probably only shifted up 1 unit because it crosses our 2. This one is definitely shifted below the x-axis. So this is probably shifted. Looks like, yeah, this one is shifted down 2 units. So it can't be C because we're shifting down. Can't be D because we're only shifting up. Looks like only 1 unit. This is the only one that we are shifted up 2 units. The range, it gets close to 2 but doesn't touch it. So it's from 2 to infinity, which matches this K value. So again, you only needed 2 things to identify the correct graph on this one. You needed to know that it was growth, which it is. So it eliminates A, and the fact that your K value is 2, which means it's from 2 to infinity is the range, which this is 2 to infinity. This is 1 to infinity. This is -2 to infinity. All right. Is that clear once we went through it? And in the end, more than half of you got it right. Well, your second option was right. Well, you're still guessing, it seems like. All right, let's try another one. And again, guys, on a test, on a quiz, once you make your decision, so let me just circle this. So the answer is B. Once you make your decision, go into Desmos and type this in and see if Desmos shows you the same answer. And just this is just to confirm what you should already know based on what it's doing here. So this 1/2 is causing a horizontal stretch. This 6 is, this tells us it's exponential growth. This x minus 2 says we are shifting to the right 2 units. And this plus 2 is saying that we're shifting up 2 units. Now, when you have a stretch and when you have a horizontal shift, it's really not that easy to determine where the point should be. Because in a standard y equals base to the x power, like this one here, it is always going to cross the y-axis at 0, 1 when you don't have any horizontal or vertical shifts. And then when you have, let's say, a stretch, let's say this was like a 1/2 and it makes the graph wider, it's going to change where your y-intercept is based on the stretch. So having a stretch and having a horizontal shift and vertical shift doesn't make it easy to determine where that point should be. Just want to point that out. All right, number 4. We have y equals 4 times 1/2 to the x plus 2, and then plus 2. So again, think about it, what's going on, and see if you can pick out the correct answer. All right, looks like all of you chose C as the answer. I'm sorry. Oh shoot, was it C or B? Forgot. C, right? All of you chose C. Okay, I don't know why I said B. All of you chose C. Was it pretty easy to determine this one? Yeah, yeah. All of you knew it was decay because of the base being 1/2. So 1/2 to the power. This tells us decay. That means it can't be A and it can't be B because those are growth. Yeah, just cross those off. And then you use the vertical shift to say, hey, we're going up 2 units. And it's pretty clear based on these two choices. This one is actually shifting up. This one is actually shifting down. So because of that, D is also not correct. So C, yeah, pretty easy to determine. And again, you can always check in Desmos to make sure during a test or a quiz. I encourage that. Yep. And, oh, that was our last example. All right, guys. Well, yeah. Any questions on today's stuff? Not too bad, right? Not too bad. So this stuff is kind of like the background info, not background. This is like our introductory to what we're going to get into, which is gonna be really good stuff talking about like natural logs and inverses. But we definitely need to have a kind of like a foundation. And this is kind of the foundation information that's going to lead us into the rest of this unit. And this unit's pretty quick. I think we will actually be done with this unit next week. Let me just see if what I'm saying is right before I stop the recording. Right, so we're on our last unit, it's exponents and logs. So we have 4.02, day 1 is Tuesday, day 2, Wednesday, day 3, Thursday. Friday is day 1 of 404. Monday is day 2 of 404. Tuesday, 406. Wednesday, another 406. We're off Thursday, so Friday next week will be 406, day 3. Okay, so we're not done next week. And then the following week after next, we'll have Monday and Tuesday for the last 2 lessons. And then Wednesday will be the review. And then our test will be Thursday and Friday. All right. Yeah, so kind of quick, right? So like 2.5 weeks, we'll be done with our last unit. All right, guys. Well, that's all I have for you. And as always, thanks for coming. And I hope you learned something. I will see all of you tomorrow.